Hello and welcome to this presentation for the Royal Horticultural Society's Level 3 Certificate in Practical Horticulture. This presentation forms part of Topic 5, Productive Growing, and is presented by Mike Roberts and Best in Horticulture. We're now moving on in this presentation to Element 2, which is the cultivation of top fruit. As usual, a quick look at the syllabus. And for this particular element, you'll be required to know the advantages and limitations of different growing systems for top fruit, the factors when planning a cropping schedule, and factors when harvesting fruit. For the application, you'll need to produce a range of top fruit in your practical sessions, and this will need to include tree management, including pruning, weed control, crop nutrition, and also harvesting. There's also the integration part of the syllabus, which we'll come to at the end of the presentation. So first of all, just a general introduction to top fruit. And top fruit is the term used to describe fruit that grows on trees. And there are many of these, which include the common apples, pears, plums, damsons and greengages, cherry, peach, apricot, nectarine, which you've missed out here, and also things like quince. We'll just do a short introduction on some of those. Starting with apple, cultivars of Malus domestica. Reportedly the nation's favourite fruit, first cultivated 4,000 years ago in the Middle East, much hybridised since then, so that nowadays there are over 7,500 cultivars worldwide. They require a well-drained, deep, loamy soil and a sheltered position, preferably frost-free. If frost's an issue, choose later flowering varieties if growing in colder areas. They also benefit from full sun to partial shade. With well over 7,500 different cultivars, it can be difficult to choose an apple variety. Factors to consider would include the space available. Some are more vigorous than others. Dessert or culinary, depending on the use that the apple's to be put to. Storage potential. Some apples are capable of being stored for a long time, while others will deteriorate quite quickly once picked. Disease resistance. Again, some cultivars are more resistant to some of the commoner diseases. And an important consideration, which we'll consider later in the presentation, is the pollination group to which an apple cultivar belongs. Taste is obviously going to be a prerequisite for a good apple variety. And there are many available to us. A lot carry an award of garden merit from the RHS, and a selection would include for culinary use Emneth Early, Golden Noble, Lane's Prince Albert and Bramley's Seedling. A dual purpose eater and cooker, suggestions Charles Ross and Blenheim Orange. And a dessert apple, we have the popular Discovery, but also Laxton's Fortune, Sunset, Egremont Russet and many others. Another popular fruit is pear, cultivars of Pyrus communis. Here we have slightly less varieties, but still well over 3,000. They require more warmth and sunlight than apples, so a more sheltered spot will be needed. And they're also earlier flowering, so they are more prone to frosts and damage to the flowers early in the season. Other selection factors are for apple regarding flavour, taste, resistance to disease and so forth. Some popular AGM varieties include Beth, Burr Hardy, Conference, Concord, Doyen de Comis, Williams Bon Chrétien and Cadillac, which is a culinary variety. Plums, gauges and damsons belong to Prunus domestica. They're closely related stone fruits. Plums with large softer fruit, gauges which are smaller, round but very sweet, and damsons which have a spicy tart flavour, making them ideal for cooking. All three require a warm sheltered site. They do have the advantage that there are less cross-pollination issues than for apples and pears. Some selected cultivars for dessert varieties include the plum bluetit, gages, Cambridge Gage, Imperial Gage and Jefferson, and plums, opal and the popular Victoria. For culinary use, plums Belle de Louvain, Czar and Pershaw are popular choices, and for damson, prune damson is again a popular choice. Moving on to cherries, cultivars of Prunus avium. Cherries particularly prefer a deep, fertile and well-drained soil with a pH of 6.5 to 6.7. They won't thrive on shallow or very badly drained sites. Cherries again flower early in the year, so choose a warm sheltered site or grow against a south or southwest facing wall or fence. A few cultivars, so for sweet cherries, Lapins, Stella and Sunburst, and for acid cherries, Morello, Nabello are examples. And it should be noted that acid cherries are less vigorous and will tolerate less light than the sweet varieties, so are suitable for north-facing sites. They're also generally self-fertile. Peaches, nectarines and apricots, cultivars of Prunus persica and Prunus armeniacum. Much loved succulent stone fruits, which do require a sunny sheltered site with protection from frost. They're very early flowering, so may require hand pollination. Examples include for peach, Rochester, Redwing, Duke of York and the very popular Peregrine. Lord Napier is an example of a nectarine cultivar. And for apricot, we have cultivars such as Moor Park, Flavorcot and Aprigold. So we've mentioned some of the main top fruit varieties, but there's a lot of hybridization that's been going on to produce ever more different varieties. And some of these have very unusual names like pluots, apriums, apriplums, plumcots, my favourite the plumpycot, or plucots. These are just some of the hybrids between different Prunus species that are also called interspecific plums. So, having had an introduction to the different types of top fruit, we'll move on to look at different growing systems available. You'll need to know the different systems available for growing top fruit, and in particular their advantages and limitations. Options include growing in the open ground, wall-trained, often referred to as restricted growth systems, and containers. So we'll start off by looking at open ground. Top fruit trees can be grown in the open ground either as single specimens in a garden or as part of a larger group, which we typically refer to as an orchard. The forms of trees and top fruit grown here would normally fall into one of three categories. Standards, which are the tallest with a long clear stem. This would be a good choice for a garden as it provides good access underneath. A half standard is shorter with less access underneath, but does provide easier picking because the tree doesn't grow so tall. Bush forms are very compact, no access underneath, but provide easy harvesting. In commercial orchards, the spindle bush form is quite popular. This is a trained form, short and narrow, enabling closer spacing and hence more trees per given area, and a wider range of varieties could be accommodated. If you're planning an orchard, there are several traditional ways of arranging trees. These include the square method, where trees are planted on the corners of squares equally spaced, and then infilled with another variety. The other variety would be thinned out as the trees age to leave the four main apple varieties at each corner. In a similar vein, the quincunx, four main apples are planted at the corners of each square with one tree at the centre. The centre tree would be removed at a later date to allow the main trees to develop further. And a rectangular growing system where trees are spaced in rows, thinned out to provide rows later on for easy access and maintenance. Consideration should be given to the types and arrangement of pollinators within these general setups. So for more information, refer to the course notes. Advantages and limitations of growing in the open ground. Trees have more space to develop and can bear heavier crops. Less skill is required to manage freestanding forms when compared to some of the trained forms. And trees in the open ground have a greater root run and access to nutrients and water. On the other hand, limitations include they're more difficult to harvest fruit from larger freestanding forms, although less of a problem for bush or half standards. Trees in the open are more prone to frost damage when in flower and can be difficult to protect. Trees in the open ground are prone to damage from wind, and fruit is often damaged by adverse weather conditions. Moving on to consider wall-trained fruit. Although the syllabus refers to wall-trained, there are other options, including growing on fences or training on a system of posts or wires. These training methods are also referred to as restricted growth forms and are very suitable for domestic gardens and for growing in a wider range of plants in a small space. Options here include growing top fruit as espaliers. Here, trees are trained against a wall with a few horizontally trained branches. These are suitable for apples and pears. A fan, suitable for almonds, apples, cherries, figs, peaches, pears, plums and nectarines. And cordons, which consist of just one main stem with short lateral growths on the side, which will bear the fruit, typically a 45-degree angle and closer spacing. Restricted forms are grown on dwarf or semi-dwarfing rootstocks and require careful initial training. Rigorous annual pruning is needed to maintain the form. So again, advantages and limitations of wall-trained fruit. Fruit trained against a wall takes up less space. The restricted root run encourages more flowers and heavier crops of fruit. And it's easier to harvest. Ladders can be leant against walls. A greater range can be produced, given the protection of walls, e.g. peaches and nectarines. Warm walls protect early blossom from frosts and help ripen the fruit. And the permanent scaffold of branches provides better support to heavy crops of fruit with less damage occurring. Limitations would include a greater level of skill that's required in respect of pruning and training, and we may not get as large a harvest as compared to freestanding fruit trees. There's also potentially a higher level of pests and diseases which will flourish in a favourable microclimate against a warm wall. And finally, growing top fruit in containers. Many types of top fruit can be grown in containers, including apples, pears, plums, peaches and nectarines. And many varieties have been developed that are suitable for small gardens, patios and balconies. These are specially bred or grafted onto dwarf or semi-dwarfing rootstocks. Minimum pot size would be 45 cm diameter, either clay, although this does tend to dry out quicker, or plastic. And we need to use a heavy loam-based compost such as a John Innes No. 3 and pay careful attention to irrigation and nutrition. The advantage of growing in containers: trees can be moved as and when necessary, e.g. to protect blossoms from frost in spring. Trees grown in containers are naturally more compact and can be easier to manage. It's easier to manage cultural operations such as pruning, pest and disease control with plants in containers, and nutrition can be carefully managed, and also water with automated systems. Limitations include trees in containers are liable to dry out more quickly and can suffer from water stress. And not all species and varieties are suitable for growing in containers. They need to be carefully chosen. However, as we've seen, there's a good range of varieties that have been specially bred for growing in containers. So moving on to planning, you'll be expected to know the factors when planning a cropping schedule for top fruit, to include the selection of a rootstock, consideration of pollination group, choice of cultivar, and site factors. So we'll start off with rootstock. All fruit trees are grafted onto a rootstock, This allows effective vegetative propagation of named cultivars and a mature fruiting tree in a shorter period of time when compared to growing from seed. The rootstock also confers properties to the fruit tree, including size and vigour, suitability for different soils, and some resistance to pests and disease. There are many different types of rootstocks available for the main varieties of top fruit, apples, plums, apricots, pears, etc. And the different type rootstocks will confer, according to the chart that we see on the screen, these range from very dwarf. So an M27 apple rootstock would be suitable for a very dwarf specimen, suitable for garden use. And then ranging in size upwards from dwarf, semi-dwarf, medium, semi-vigorous, vigorous, very vigorous. We've got options for all the different top fruits. This is quite a complicated subject, and you'll find specific properties and applications for different rootstocks that are included in the course notes. So for the purpose of the presentation, we'll move on to pollination group, and in particular looking here at apples to start with. For fruit to develop, a flower must be pollinated with pollen from another flower, ideally from a different plant. There are some cultivars which can self-pollinate, but better cropping will result from cross-pollination. Compatible cultivars should be planted together to ensure effective cross-pollination. And cultivars are arranged in pollination groups to make it easier to select compatible pollination partners. It should be noted, though, that pollination groups are based on flowering time rather than anything else, since the recipient and the pollen donor need to be flowering together for pollen to be effectively transferred. So, looking at pollination groups for apples, they're grouped into 7 pollination groups, ranging from group 1, which are the very earliest flowering apple cultivars, through to group 7, which are very late flowering. As an example, a group 1 apple would need a pollination partner chosen from group 1 or 2, and a group 5 apple would need a partner in groups 4, 5 or 6. In other words, one either side of the main group. So as an example, if we took Discovery, which is a group 3 apple, to choose a pollination partner we could choose something which was in the same group, for example Falstaff, or alternatively something from group 2, Egremont Russet for example, or something from group 4, Ellison's Orange. Now, pollination groups can be further confused because certain apple varieties are known as triploid, which means that they possess 3 sets of chromosomes instead of the usual 2 sets, which is the norm for most cultivars. This unusual genetic makeup grants them increased vigour, but also results in sterile pollen. To successfully pollinate, they need a compatible partner. However, since they are unable to pollinate this partner themselves, a third cultivar is necessary to facilitate pollination for both the partner and the triploid variety. This can seem rather confusing, so in diagram form, if we take an example of a triploid apple cultivar, the popular Bramley seedling, this is a triploid and belongs to the group C pollination group. Bramley seedling produces sterile pollen, so it will need another cultivar from group C or similar to pollinate it. So as an example, we might choose Discovery. The Discovery apple can pollinate the Bramley seedling, but because Bramley seedling is sterile in terms of pollen, it won't be able to reciprocate and pollinate the Discovery apple. So this is why we need a third cultivar. In our example here, Beauty of Bath. This is from group B, so it's compatible. And Beauty of Bath can pollinate also the Bramley seedling, but both Beauty of Bath and Discovery will be able to pollinate each other. And hence we have 3 cultivars all able to successfully cross-pollinate each other. Some further complications with pollination. Pollination groups are also applied to pear, plum and cherry. I haven't got sufficient time to go into these in great detail here, and the following websites can provide useful guides and charts. The Ashridge Trees website has good sites for pollination of pear trees, cherry trees and plum trees. When it comes to peach, apricot and nectarine, these flower particularly early in the year and frost can damage these early blossoms, so we may need to provide protection, so growing these against a wall makes this much easier. At this early time of the year there may also be few insects around to pollinate the flowers, so hand pollination of particularly peaches is quite commonplace. So with so many varieties of top fruit available, it's important to select the right cultivar. Factors will include knowing your soil type, giving consideration to the space available, and thinking about any disease resistance which different cultivars might possess. For all of these, soil, space and disease resistance, a choice of rootstock will also affect this. We need to bear in mind hardiness, the pollination group that the plant belongs to, the use, dessert or culinary, storage potential, and of course ever important taste and texture, and from a practical standpoint the pruning requirement of the plant. Just to look in a little bit more detail at some of those factors, when choosing a site there are several factors which need to be considered when choosing an appropriate area for production of fruit. It can be summarised as climate with regard to temperature and rainfall, soil, aspect, elevation, in other words the height of the site above sea level, the amount of wind exposure, the availability of water, and for commercial enterprises the availability of labour. Labour will of course be needed to pick the fruit once it's ripe. So for site conditions, the climate, we need a long growing season for most top fruit with a minimum of 6 to 8 hours of sun per day. It's also noted that a period of cold is required to initiate flowering in most top fruit varieties such as apples and pears, and rainfall should be greater than 875 millimetres per year. For most top fruit, a fertile loam-based soil with good drainage and a depth greater than 500 millimetres. These are trees after all, and some varieties will require greater depth, such as cherries. An average pH for most top fruit would sit between 6 and 6.5. In terms of exposure, we require some shelter from damaging strong winds. This is required to prevent structural damage to the trees, but also pollinating insects prefer more sheltered sites and are discouraged if it's too exposed. Frost pockets should be avoided. Hollows and low-lying areas allow cold air to collect, increasing the likelihood of frost that will damage flowers. We need to have a brief look at harvesting. Several factors affect the harvest date for top fruit, such as the number of fruit on a tree. The fewer the number of apples on a tree, for example, the more rapid fruit matures, resulting in an earlier harvest date. A heavier crop will delay the harvest. High levels of nitrogen generally delay red colour development and induces flesh softening and early fruit drop. And temperature throughout the growing season will have an effect. Apple harvest, for example, is slightly delayed in a year with unusually cool temperatures. Different apple cultivars vary in their response to temperature though. How do we know when to harvest? Ripeness testing. There are several ways to ascertain whether the fruit is ripe or not, and these include a change in the colour of the fruit, a change in the firmness, and here a field test can be used, or commercially a penetrometer can be used to measure the firmness of the fruit. There'll normally be a change in taste, the flavour of the fruit as it ripens, and a change in sweetness as the starch in the fruit is converted to sugar. And the sugar content can be measured using several tests, including a Brix refractometer, in which a sample of the fruit juice is placed into the refractometer and a reading is taken to gauge the amount of sugar within the solution. Other clues to look at to know when to harvest. For apples, these are typically ready to harvest in late summer to late October, but the exact time depends on the variety and weather. The skin may turn from green to red or yellow. And if we gently twist the apple upwards on the tree, if it comes away from the branch with the stalk, it's ready. Pears. Should be noted that pears don't ripen fully on the tree and are usually picked hard and ripened off the tree. Pears should be firm to the touch, but slightly soft around the stem. They may have a subtle change of colour, perhaps not as dramatic as for apples, and they may change from green to a little golden in colour. The stem should separate easily from the branch when the pear is gently twisted. Pick plums when they're ripe and have a dusky bloom on the skin, but before they get too soft. Check the tree every 3 days for newly ripened fruit, as plums will ripen over a prolonged period. Commercially, hand picking is still the norm for most top fruit. It allows careful selection of the fruit, and it allows for careful handling to avoid bruising. Mechanical pickers are available, and these remove the fruit by gripping the trunk and shaking the fruit from the tree, which is then gathered from the ground. This is common for cider apples, where appearance and storage of the fruit is less important. Cold storage removes field heat and allows a crop to be stored for many months, particularly in low oxygen environments. We'll next move on to look at the rather complicated subject of pruning of top fruit. To start with, summarising the reasons for pruning, principally to establish and maintain the shape of the tree or bush, maybe to limit size. This would be particularly the case with restricted growth forms. It follows that we want to maximise our yield and maintain the health of our plant, and here paying attention to the 4 Ds, which as any RHS student knows stands for dead, diseased, damaged and displaced growth, which needs to be removed at pruning stage. Pruning will generally fall into one of 2 categories. Formative pruning, which is pruning a newly planted tree to establish a framework of branches. This may last from 1 to 4 years. Thereafter, routine annual pruning is needed to control growth, maximise yield and maintain health. When planting a new fruit tree, especially if we're growing it from a 1-year-old or 2-year-old maiden, the first 3 to 4 years will be spent developing a framework. In this time, don't allow fruit to develop in quantity, as you want the plant to put its energy into vegetative growth. As we've seen, there are many different growth forms for top fruit. So as an example, we'll look here at formative pruning required to produce a bush form of apple. So in the first year, in November to March, we might receive a feathered maiden to plant. And so the first thing would be to cut the main stem back to a bud or a lateral at about 60 centimetres for a dwarf bush or 75 centimetres for a slightly taller bush. This will then encourage the plant to produce some lateral branches. In the second year, we're going to select 4 of the primary branches that have formed wide angles to the stem. These are going to be permanent branches that will bear much weight in coming years, and a wide branch angle is structurally stronger than those branches which form a narrow angle to the main stem. Cut back vigorous ones by half, less vigorous ones by 2/3, pruning to outward facing buds. Remove any unwanted branches. In the third year, select further 4 well-placed new growths growing off the main laterals that have already been established, and these again are going to form permanent branches. Cut back vigorous ones by 2/3, and again pruning to outward facing buds. Pruning to outward facing buds will help to develop the goblet shape that we require an open-centred bush which has greater airflow. In year 4 and onwards, the branch framework has been formed and the leader pruning can cease, unless growth is weak. Leave laterals on the outer part of the tree unpruned, but cut back laterals on the inside to 10 centimetres. This again will encourage an open-centred bush with greater airflow. So moving on to look at more routine pruning, apple and pear. The main aim of winter pruning is to maintain an open-centred goblet-shaped crown with well-spaced main branches radiating from the trunk. This allows light to reach all parts of the tree and ensures good airflow through the canopy, resulting in better quality crops and fewer pests and diseases. Pruning should be done while the tree is dormant, after leaf fall and before it starts growing again, and this is usually between November and early March. A consideration for apple and pear pruning is to know whether our cultivar is a spur bearer or a tip bearer. Many apples produce their flowers and fruit on short spurs. These are short flowering or fruiting side shoots spaced along the main length of the main branches. Tip bearers, on the other hand, these are varieties bearing fruit partially or exclusively at the tips of shoots. Examples of these include Worcester pearmain and the popular Bramley seedling, which is a partial tip bearer. So we'll consider pruning of a bush apple tree, and in this instance we're referring to a spur-bearing apple. We'll take it as read that we're removing dead and diseased growth, but moving on, firstly removing crossing shoots that are rubbing together. Branches which cross other branches further up the tree should be removed in their entirety. Prune out strong inward-facing shoots. Again, we want to encourage an open-centred bush. Remove any downward-growing shoots. Shorten the previous year's growth on each of the main branches by a quarter or a third, depending on the vigour of the plant. Leave young side shoots unpruned so they can develop fruit buds in their second year. As spur systems develop along the length of the main branches, these might occasionally need to be thinned out if they're getting too crowded. For larger, more mature trees, reduce excess height or overcrowding by shortening larger branches by about a third. Prune to a strong outward and upward facing side branch that's at least 1/3 of the diameter of the branch being pruned. For tip-bearing cultivars, reduce the length of older, long fruited branches by up to a quarter to a strong, younger side shoot positioned closer to the main trunk. This will prevent the branches becoming too long. When pruning a mature apple tree, you should be careful not to remove too much growth in any one year. Excessively hard pruning can result in the production of lots of vigorous vertical shoots from the branches, which can cause crowding in later years. We'll next look at the pruning requirement for restricted growth forms, such as for cordons, espaliers, fans and stepovers. It should be noted that the pruning of these types of restricted growth forms would be normally done in summer. Summer pruning restricts the growth on these forms, whereas winter pruning is used for tree forms. So summer pruning would normally take place round about July or August. On our example here of an espalier, once the final tier is formed, entirely remove the new replacement central shoot. Cut back side shoots growing directly from each of the horizontal branches to 3 or 4 leaves above the basal cluster. The basal cluster refers to a small cluster of leaves growing right at the bottom of the stem. So taking this into consideration, we then count 3 or 4 leaves up from that and there make our pruning cut. Later on in the year, side shoots that have been previously pruned can then be cut further back to one leaf above the basal cluster. It's best to delay any of this type of pruning until terminal buds have formed at the end of the lateral shoots. This would normally be in July or August. Pruning sooner than this will mean that the tree will be encouraged to produce some new growth, which will then need to be pruned off anyway later on. Stone fruits such as plum, peach, nectarine and apricot and cherry all have their own slightly different pruning requirements, which are referred to in the course notes, but it should be noted that these should be pruned in spring or early summer rather than the winter to reduce infection by silver leaf disease. We'll next move on to looking at maintaining plant health. As with all other plant cultivation, maintaining plant health is essential for maximising productivity. This will mean controlling competition, for example from weeds, getting the correct nutrition for each plant, controlling any abiotic factors or dealing with environmental conditions, and control of biotic factors such as pests and diseases. There are several reasons for controlling weeds under top fruit, and these include they may provide habitat for insect pests which will predate fruit crops. Long grass and weeds make it easier for crawling insects to bypass any preventative measures we might have put in place, such as grease bans. They can make it harder to carry out cultural operations to the trees, such as the removal of suckers. And weeds not only look unsightly, they actually compete for trees for water and nutrients. In commercial orchards, herbicides are used to control weeds in strips each side of the rows of trees to a distance of approximately a metre. An organic approach might use a mulch to suppress weed growth. Weed mats can also be used to good effect. These are put in place after the trees have been planted and provide useful protection from competition by weeds in the early development stage. Nutrition will be important to get a good crop from our top fruit. And of the three main nutrients, nitrogen required for strong growth of leaves and shoots, and top fruit require nitrogen in the spring and summer to produce new shoots and flowers. Phosphorus is particularly important during periods of new growth of plant tissue, for example when new roots and flowers are formed, and during cell division in the development of fruitlets. And peak potassium uptake occurs later than that of nitrogen, being important for yield, but also having a major influence on fruit sweetness. In addition to the three main macronutrients, calcium, another macronutrient, common deficiency in apples is calcium, leading to bitter pit. Actually, the problem here is not so much the lack of calcium, but the transport of calcium dissolved in water through to the fruit. The key here is to ensure good irrigation, but we can also spray with calcium nitrate to help calcium get to the fruit and avoid the unsightly bitter pit. Magnesium is important in ensuring good growth, but at relatively low levels. It has a critical role to play in leaf growth and good flowering with minimal fruit drop. The sign of magnesium deficiency is interveinal chlorosis on the older leaves. Spraying with magnesium sulfate, Epsom salts, or we can apply directly to the soil. Micronutrients boron and zinc have a critical role to play in bud development, flowering and fruit set, and are the most widely applied micronutrients. Fertilizer regimes. In our presentation here we're concentrating on three possible fertilizer regimes. Method 1, each year use a potassium-rich general fertilizer, a rose fertilizer for example, in late winter, in doses directed by the manufacturer. Method 2, Each year use Grow More fertiliser. Apply 100 grams per square metre for dessert apples in bare soil and 140 grams per square metre for dessert apples in grass. For cooking apples, use 50% more fertiliser. This is because the fruits are much bigger. And method 3, where an organic regime is being followed, use the weights stated in method 2 but substitute Grow More with dried poultry manure pellets. Organic potassium instead of sulphate of potash can be used every 3 years. There are several environmental factors which can affect the productivity and health of our crop. Wind, scorching of leaves and structural damage to branches and loss of fruit. So try and always choose a sheltered spot for top fruit, perhaps providing a windbreak or growing against the protection of a wall. Frost can be extremely damaging. After all, no flowers, no pollination, no fruit. So damage to blossom, especially on early fruiting varieties, is a particular danger. If you live in a particularly cold part of the country, where frosts are commonplace, try and choose a later flowering cultivar, or aim to provide protection. Irrigation and water. Drought can lead to premature fruit drop. This shouldn't be confused with the June drop, which is the process when apples will naturally abort excess fruit. But periods of drought as the fruit is developing will cause them to develop less well and may prematurely drop. And we've just talked about nutrients for top fruit, so you'll need to be aware of the signs and symptoms of nutrient deficiency. In the photograph here shows potassium deficiency in apple with characteristically browned margins to the leaves. Looking at some biotic health risks, in other words, pests. These are numerous for top fruit and include a range of mammals, rabbits, squirrels, deer, voles, mice, etc. These can attack the stems and trunks of the plants, but also fruit as well. Birds, in particular pigeons and blackbirds, will predate fruit. And there are many insect pests which can be an issue, including aphids, which will suck the sap of plants, thus weakening them, but can also be transmitters of viral diseases. Woolly aphids can be particularly debilitating on top fruit, as can scale insect, and a number of moth species. Ermine moth, characterized by these tent-forming caterpillars, which typically weave a dense web. Codling moth, the larvae will burrow into fruit, particularly apples. And winter moth can seriously damage blossom and in its bud form. Controlling pests for rabbits, rabbit fencing may be effective. And for small plants, bird netting could be used, although for taller top fruit this isn't very practicable. Bird scarers could be effective. And for insect pests, we could try pheromone traps, grease bands. These are particularly effective against winter moth. As they emerge in the spring, they crawl up into the trees to lay eggs, and so the grease bands will trap them on their way. Encouraging natural predators is always a good idea. Ladybirds will predate a wide range of insect pests, including aphids and woolly aphid. And so operating on an organic regime to encourage natural predators could be a good tactic. Where we want to use pesticides, these can be quite tricky given the size of many top fruit trees. Organic pesticides, including pyrethrum, are fairly short-lasting. These are contact herbicides. Or for longer duration, a synthetic contact insecticide, such as the one shown here. A number of diseases can affect top fruit, and these can be divided into, first of all, fungal diseases, which include fungal canker. This is quite a serious disease of apples and pears, causes lesions on the stems, and can eventually lead to the death of a whole stem. Honey fungus will attack a wide range of plants, not just top fruit, and is particularly serious as it can result in the death of the whole tree. A very specific fungal disease, peach leaf curl, causes this characteristically misshapen leaf. And mildew will affect a wide range of top fruit, including apples and pears. A specific disease affecting pears includes pear rust. And silver leaf will affect a wide range of plants, including plums, cherries, peaches, and nectarines. Bacterial diseases are rather fewer, but can be potentially very serious, including bacterial canker, which produces the characteristically oozing lesions, as we can see in the picture here. It also leads to a phenomenon called shot holing in prunus species, where the leaves develop small holes, looking as though they've been peppered with lead shot. And another serious bacterial disease is fire blight. This usually infects the trees through their blossoms and starts at the ends of the branches and works its way backwards, leading to a characteristically brown leaf which hangs onto the tree as though it's been scorched by fire. Both bacterial canker and fire blight are particularly serious, and any infected shoots should be removed as soon as possible and disposed of. Controlling disease on larger trees can be quite tricky, as it's difficult to spray with fungicides even if these are available. So tactics would include growing for resilience, making sure that our plants grow strongly and are able to resist any disease or get over it quickly. This often means avoiding over-fertilizing, which could produce very soft, weak growth prone to disease. Maintaining good drainage around the trees, and in particular avoiding water stress. Water stress can leave the plant open to diseases like mildew, and will also weaken them and make them prone to other diseases. When choosing our plants, we could choose those varieties which are more resistant to particular diseases, and for example, peach Rochester is said to be resistant to peach leaf curl. Pruning at the correct time is an important consideration. Silver leaf spores are active in winter, so we should prune stone fruits in spring or summer to avoid the spores getting into open cuts. Being vigilant and cutting out infected shoots that are affected as early as possible. And prune to promote a good air circulation. This is particularly important to overcome diseases like mildew. At all times we should practice good hygiene, including disinfecting tools, removing infected growth and leaves. So finally, just a few words about the integration part of the syllabus. First of all, the impact of site on the production of top fruit. Well, we've covered this one earlier in the presentation, but also see topic 2, element 1, which also deals with factors to do with site preparation. The importance of evidence-based decisions in productive growing. Refer here to topic 3, elements 3 and 4, which looked at best practice and evidence-based decisions. Implement findings of recent horticultural research as it applies to the cultivation of top fruit. Organisations such as the Agriculture Horticulture Development Board, the University of Reading, DEFRA, the Department for Environment, Food and Rural Affairs, and Fruit Advisory Services Team, or FAST, all produce useful publications outlining current developments. And finally, planning and maintaining plant health in the cultivation of top fruit. We've covered that earlier in this presentation, but also see topic 4, plant health, and the extensive coverage of specific pests and diseases in the course notes for this element. So what next? As you'll have gathered, this is another big element, so please ensure that you read the course notes for a comprehensive appreciation of the subject. You could do further research by selecting cultivars for a range of top fruit to produce a schedule for a site, and undertake some research into current best practice for fruit growing. So that brings us to the end. Thank you very much for listening, and again, we hope you found this useful and informative, and I look forward to seeing you again in another presentation. So this is Mike Roberts on behalf of Best saying goodbye for now.